Hello, welcome to a demonstration on how you can use linear regression equation to solve a real business problem. In this particular case, we have a data set of a pizza company. They produce pizzas and they incur some overheads, and we want to be able to use linear regression equation to be able to predict how much of the overheads are actually going to be incurred for a certain number of pieces that's actually produced, right? So it's going to be a very useful and practical example of how you can really appreciate linear regression equation. But of course, to begin with, working definition of what a linear regression equation is. It is a mathematical representation that describes the relationship between two or more variables in a linear manner. But in this particular case, we only have two variables. So we have an independent variable and a dependent variable. And more specifically, our independent variable is going to be the pizzas, the quantities, right? That's going to be our predictor of the overheads, which is our dependent variable. So because of that, this actually becomes a simple linear regression equation, right? Okay. So again, what is really the goal of linear regression is to find the best fitting line that can minimize the difference between the actual observed values of the dependent variable and the values that are predicted by the linear equation. So we're trying to minimize that, right? So it's a very, very important concept that can really come in handy. So again, this process will involve the estimation of the values of the slope, right, which at times we also refer to it as a coefficient, and the intercept, which we also at times refer to as a constant, right, that results from the best fit of that given data. So linear regression in practice generally used for a variety of purposes. That includes prediction. In this particular case, that's what we want to do, but you can also use it for trend analysis, and you can also use it just for the purpose of understanding the relationship between variables, right? Now that the working definition is out of the way, it's time for us to really think a little bit about the linear regression equation, how it's actually presented, the equation itself, right? It's a y is equal to mx plus b, right? Sounds a little bit overwhelming. All right, I'm sure you remember this from your algebra days. Maybe in college intermediate algebra, you came across this very insightful equation, right? But what does this actually mean? So the y would be our dependent variable, right? And as we've already said, dependent variable in this case is going to be the overheads, right? So the overheads actually depend on the quantities of pizzas, okay? Otherwise, we wouldn't have any costs to incur if we're not producing the pizzas, right? And the coefficient is really that measure that enables us to see how much every overhead cost is being incurred for every additional pizza we actually produce, okay? And then, of course, we multiply that with the quantities that were actually produced, and then we add that to our constant or the intercept, right? Intercept is actually the constant. But now to bring it further down to earth, for lack of a better term, let's rewrite this particular equation using the problem we actually have here, right? Okay, so the y is actually our overhead, right? Okay, and the variable cost, per unit, so which means that cost that's actually added for every additional quantity of pizza we actually produce. What is that? That is actually added to the overall overheads, and then of course to that we add the fixed costs. Now, it's also important to understand what these terms, because I know that I'm just throwing all these terms at you, and then you say, okay, you've just thrown so many terms at me. What do they actually mean? So, okay. So when we talk about the overheads, we're talking about the overall cost that's actually incurred by the business. But now the overall cost is actually divided into the variable cost, so the costs that vary by activity, right? This could be raw material that goes into the pizza, right? The oils, everything, okay? So if we do not produce the pizzas, we do not incur the variable costs, okay? So when we produce pizzas, of course, we incur variable costs. So they vary with activity. What is fixed costs? We do not have to be producing anything. We still incur them, right? That's why we want to make sure that we're at least producing something so that we'll be able to absorb the fixed costs. So the fixed costs could be the salaries, those people who are paid salaries. They're not paid hourly wages, right? So we have to pay them insurance, rent. We have to pay even if we're not producing anything. So it's important to understand and just appreciate that. Otherwise, the independent variable is actually the quantities that's actually produced in this particular case. So now that we have brought the equation down to earth to where our problem is, now we can then try to figure out how we can use Excel to find the quickest way to solve this particular problem. You'll be surprised that Excel can really simplify this. So Excel can simplify this by generating what we call a scatter graph. So a scatter graph, where is it? So if you click on insert, under chart group, there is a scatter graph. But of course, we have to select the data we want to use, right, to generate that particular scatter graph or scatter chart. So if I go there, click on it, and I want the very first one, and before you know it, it is actually generated the scatter chart. But then, of course, we want to just clean it up so that these data points are a little more meaningful here, okay? So what we need to do, we can go to the y-axis. We see that it's actually beginning, the first value is beginning after 6,000. So we can change the minimum to 6,000, okay? And then the x-axis here, we can see that the quantities are beginning after 1,000. So in other words, we do not produce less than 1,000 pizzas, right, to sustain our business. So again, what we actually do, we're not changing any numbers at all. All we are doing, we just want to make our chart a little more presentable, right? So now that it looks a little bit better, we can now draw the line of best fit, the one that generates this particular equation. So we click on the chart elements and we go to trend line, put a check mark on it. Now we can see the line. And then when we hover on trend line, there is an arrow that's pointing to the right, which means there are more options available. So click on that and we want to go to more options. And under more options, there is a display equation on chart. So I click on it. Now we have that chart. And we can also display the R square, right? And we can move it somewhere where it's a little more visible. Now that we have this, of course, this is our equation, which is the equivalent of that, right? Okay, so it is actually calculated for us the coefficient, which is $2.09. So it's actually telling us that for every additional pizza that's actually produced, the overheads will increase by $2.09, right? For every additional unit of pizza that we produce, the overheads will actually increase by $2.09. And our fixed costs, right, which is actually our intercept right there, it's actually 3,998.3. So it's actually telling us that the fixed costs that we that are constant, we have to pay insurance, rent, salaries, and so forth, is 3,998. Okay, and now the X actually represents the quantity of pizzas, right? So which means that here the only two things that we do not know anything about is the Y, also the overheads, right? But if we know what quantities we want to produce, that X, then we are actually able to estimate the overheads, right? So here already, as you can see, it's actually already it's bringing meaning to our linear regression equation. However, I need just to clarify why I include the R square. R square is simply telling us how much of the variation in the overhead is being explained by the quantities of pizzas. So it's telling us here that 89% of the overheads can be explained by the quantities of pizzas that are actually produced. So it gives us some confidence as we then go ahead and use this equation to perform our estimates, right? So very important to understand the meaning of that. So now that we have our equation with most of the values there included, right? We can now ask a question. What about if we're going to produce 1,800 pizzas? Okay. How much overhead are we going to incur because of that? Okay. So maybe we can put it on this side here so that we can actually see here. Okay, so here we want to calculate the y is equal to, okay, in this case we want to estimate how much overheads will actually incur if we produce 1,800 pizzas. So we'll probably just do two examples so that we are actually able to see how this will pan out. So we enter the equal sign, 2 point, now we need an open parenthesis, okay, because we want to multiply this coefficient or this slope by the number of quantities of pizza. So x represents the number of quantities. In this case, we picked an arbitrary number, 1,800, because we noticed that on this list it was not there, right? So we just wanted to estimate something else that is not on the list, plus the fixed cost, 3,998.3. Press enter. It's actually telling us that if we produce 1,800, approximately our overheads will be 7,763. And if we look here, we have got 1,750, so this is actually higher than that. Okay, so let's try another one with our newfound solution from Excel, right? Okay, let's say, for example, another one, maybe we want 2,000, okay, let's say 2,200, okay, multiplied by 2,200 pizzas plus the fixed cost that we have to pay regardless. Here it's actually telling us that our overheads will be estimated at 8,600. So you can see the power of the linear regression equation, right? It's very practical. You can imagine in an organization, we're trying to figure out, okay, we want to produce more pizzas, but our overheads, we want to plan for our overheads, right? We can actually use this equation to estimate that. And then we can use that in our budgeted numbers. And then eventually when we have the actual numbers, when that time is actually lapsed, then we'll be able to go back and compare how far off we were and so forth, where did you go wrong and so forth. Because of course, you may still end up having to incur more overheads, maybe because there was a fixed cost that you had not anticipated, or there could be a variable cost that was actually wasted, the raw material that was actually wasted during producing those pizzas, or there was some raw materials that got spoiled and we decided to throw them away and so forth. So that actually could be the reason for that. Then you can actually begin to have the reason why you were off, what caused the differences to actually occur. So very, very practical way of actually looking at business. And I must say, I've actually used this in practice. I worked as budget and planning manager for a Fortune 500 company, and we're using quite a lot of these equations so that when we're actually working on the budgeting, we can be as close to reality as possible. And if we end up not being as close enough, we should have an explanation why we're not able to be close enough. So I'm hoping that you can take that deeper meaning of the application of a linear regression equation, because many times when we initially introduce some of these concepts, they are not as meaningful until we actually find their use in real life. Otherwise, that's all I have for you. Thank you so much for watching. And again, like the video, share the video, and be sure to subscribe to the channel. And bye for now.